Hello friends. So in continuation with previous video regarding how to improve the bedding capacity of the ground, we need to do some calculations based on the theory given by Binky and Lee. So let's take a problem, the application of the theory given by Binky and Lee. We will see a strip footing. So we are going to take a problem on reinforced foundation bed or reinforced soil bed. So let's say you have a problem like this. You have a strip footing embedded into sandy ground, sandy bed, having the value of phi equal to 39 degree, and total unit weight is 60.3 kilonewton per meter cube, and the value of NQ based on phi value are all known to you. The NQ is 65 and N gamma is 85, the bearing capacity factors, and the size of the footing B equal to 0.9 meter. That is the strip footing. So friends, in this strip footing, the depth of the footing D or DF is 0.9 meter. So in this problem, the number of reinforcing layer one, 2, 3, 4 and 5. You have got planar geosynthetics, the linear density ratio LDR is taken as 1. Planar geosynthetics. Say it is geotextile or geogrid. So there is the linear density ratio, which we call it LDR, and this is called delta U by the width of the footing equal to delta V upon the width of the footing. So this is delta U and this is called delta V equal to 0.3. And the intensity of loading is also known to us. So the intensity of loading is 1419. So here 0.3 kilonewton per meter. That is the intensity of the loading over the width of the footing equal to 0.9 meter. So the value of bedding capacity ratio BCR is going to be 3 times. What is BCR is already explained in the previous video. That is the intensity of loading in reinforced earthbed upon the intensity of loading or the safe bearing capacity in unreinforced ground. That is called BCR. So bearing capacity ratio is 3. And here uh, the you can you have all the information, number of reinforcing layer capital N equal to 5, that's given to you in this problem. Gamma is given to you as 16.3 kilonewton per cubic meter. The geometry of the footing is known to you, 0.9 meter, and the depth of the footing is also 0.9 meter. And the intensity of loading is also given to you. So what will be the value of QR? Let's see the solution of this problem. So the target is we want to improve the load carrying capacity of this footing by 3 times. So that's the target. And the solution, as you know, all of you know it, that what is the tension developed? This delta U, you should calculate. So delta U will be 0.3 into B, that is 0.9, so it becomes 0.27. So the first reinforcing layer below the base of the footing is called Z1. Therefore, Z1 equal to 0.27. Now, delta V can be calculated as 0.3 multiplied by B, that is 0.27. So this is going to be 0.27 between 2 consecutive layers. This is also 0.27, and the depth is measured from the base of the footing. So the first layer, number 1, this is going to be Z1. Similarly, from here up to the second layer, it will be Z2, and from here up to the fifth layer, this becomes Z5. So that is the depth. So we want to first find out the tension that is going to get developed. So before that, let us see all the info that's given over here. You have been given n equal to 5. You have been also given that the settlement, permissible settlement of the footing is 25 mm. So that is the permissible settlement, and the modulus of elasticity of the sandy soil is to be taken as 360 kg per cm square. So it is 360 kilopascal. So that is the value of modulus of elasticity of sandy soil, sandy bed. And the value of Poisson's ratio mu is given for the sandy bed as 0.3. So friends, with these informations, let's calculate the safe bearing capacity of the sandy bed. What is the safe bedding capacity? Let's say it is Q naught. It will be 1 upon factor of safety into QNQ plus it is a strip footing 0.5 gamma B N gamma. Let's calculate by using this particular expression given by Terjagi. So naturally, if you substitute factor of safety as 3 and Q, you can find it out. It will be 16.3 gamma into df, that is 0.9, that is the value of Q. NQ is already given to you as 65 plus 0.5 into 16.3 into 0.9 into 85. So if you calculate this, you can take your calculator and easily you can calculate it, the value. This becomes equal to 500 divided by 3, 525.67. 525.67 kilopascal. Now, bearing capacity has to be improved by 3 times. So, by reinforcing the ground with this geosynthetic material, these are the geosynthetic material, 5 layers. These are the reinforcing element 1, 2, 3, 4, and 5. So, 5 layers of geosynthetics. Say this is geotextile. It could be planar or geogrid. All right. So 3 times means the loading intensity for R means reinforced earth. So safe bearing capacity of the sandy bed, and there is the bearing capacity or load intensity for a reinforced bed. Reinforced bed. So QR is going to be Q naught multiplied by bearing capacity ratio. So BCR is 3, you multiply it by 3. So if I multiply it by 3, I get it 1577. 1577 kilonewton per meter square. So this multiplied by this footing width. So in kilonewton per meter, 1577 multiplied by what is the width of the footing? It is 0.9. So if you multiply it by 0.9, it becomes 1419.3 kilonewton per meter. This is the intensity of loading that has been shown over here on the strip footing. So friends, you have seen this. Now let's check the settlement aspect. So settlement permissible, you should compute the settlement. And the settlement here will be given as Q naught into width of the footing into 1 minus Poisson's ratio square into the factor IW divided by modulus of elasticity of the sandy bed. So Q naught is now already known to be 525.67 multiplied by B 0.9, mu 0.3, IW is 2 for a strip footing. And ES value is already given to you as 36,000 kilopascal. Let's substitute all the values. So 525.67 into 0.9 multiplied by 1 minus 0.3 square bracket closed into 2 divided by 36000. This gives you in meter 0.0234 meter. So 1, 2, 3, it becomes 23.4 mm, which is less than 25 mm. So the permissible settlement is given over here as 25 mm, and the settlement I have calculated is only 23.4, which is less than 25 mm, less than equal to this. So it's okay. No issues. Now, how will you find out? This is the first part, isn't it? This is the first. First, calculate the safe bedding capacity, calculate the intensity of loading. Then, for BCR equal to 3, and then you should go for computation of the settlement, check it, and the third part is compute as per Binkit and Lee. So, as per the research paper given by Binkit and Lee, the tension developed is given by the expression, a famous expression that I have already given to you is 1 upon n and a dimensionless force factor J, which is a function of Z by B multiplied by B minus another force factor that is called I, which is a function of Z by B multiplied by delta V into Q naught into bedding capacity ratio minus 1. This is the famous equation given by Binky and Lee. So friends, this is the expression already explained to you. Use this and you can calculate the tension for various value of J and I. What is Z1? Z1 is 0.27. What will be Z2 for the second layer? It will be 0.27 multiplied by 2, that is 0.54. Similarly, Z3, Z4, Z5, you can calculate it and refer the chart given by Binky and Lee, and then you can very well calculate the value of TD, tension developed. So let's calculate the tension developed. Q naught is already known to be 525.67. BCR is 3. 3 minus 1, this becomes 2. Delta V is going to be 0.27 and B is going to be 0.9. But this I and J are the factors, load factors, and these load factors are functions of Z by B. So what is this Z? The first layer, the Z is 0.27 divided by 0.9, so it becomes Z by B becomes 0.3. So for layer 1, so friends, let's calculate. So the solution proceeds in a tabular form. So in a tabular form, the calculation can proceed. Z by B. N number of layer equal to 1. Total number is going to be 5 for the first layer. So layer 1. So for first layer, so we can have different layers. Layer 1, layer 2, layer 3, layer 4, and layer 5. Total 5 reinforcing layers. So friends, you can calculate Z by B. Z1, first layer, is going to be 0.27. Z is always measured from the base of the footing. So this is going to be 0.27 divided by 0.9. So it becomes 0.3. So 0.3. Then second layer, Z2 becomes 0.54 and 0.54 divided by B, that is 0.9, it becomes 0.6. So Z by B equal to 0.6. Layer 3, 0.9. Layer 4, 1.2. Layer 5, it becomes 1.5. So you have got Z by B value. And if you see the chart, last time I have already given to you Z by B. And on the y-axis, you have got I, J, and M. All the load factor can be obtained from the chart. And therefore, you know the value of J, you know the value of I, you know the value of J, having got the value of I and J, I can calculate TD. So tension developed, the unit will be kilonewton per meter width. So the tension that is getting developed in the reinforcing layer, layer 1 to layer 5, can be computed. So n is going to be 5. It remains constant. Total number of layer, n is total number of layer. But j and I will keep on changing depending upon the value of z by b, which is changing. So z by b, it is going to change, and therefore you will find I equal to 0.28. For 0.3. Then the I value is going to be 0. Approximately 23 or less than that for 0.6, roughly 0.222 from the chart, and the value is going to be I for 1.9. It is 0.17 approximately, and for 1.2 approximately it is so much, and for it is so much. Now what is the value of j? J is 0.36. For 0.3 z by b, then it is 0.35. J value, then it is going to be 0.34. Then it is 0.34, almost constant. Here also it is 0.34, almost constant. So from expression 1, this expression, substitute the value and calculate the value of TD. So it will take little time to calculate. How will you do it? Now it's quite simple. Let's all do it. So friends, please take your calculator, and with me you also calculate. So JZ by B for layer 1, 0.36 multiplied by 0.9 minus I is 0.28 multiplied by 0.27, right? 0.27 multiplied by 525.67 multiplied by 3 minus 1, that is 2, divided by number of reinforcing layer 5. It is 52.23. Friends, TD is 52.23 kilonewton per meter. So layer 1 you have calculated. So simple. Now go to layer 2. What is the value of I and j? 0.35. So 0.35 multiplied by 0.9 minus the value is 0.22. 0.27. 525.67 into 2 divided by 5. This is 53.74. 53.74. Go to the next, third layer. Now Z by B is going to be 0.9 now. From 0.6 it has become 0.9. And J is 0.34. So 0.34 into 0.9 minus 0.17 into 0.27 multiplied by 5 to 5.67 multiplied by 2 divided by 5. This gives you 54.7. Go to the fourth layer. You have total 5 layers. Fourth layer. Z by V is now changing to 1.2. And therefore, J is 0.34. So 0.34 into 0.9 minus 0.15 into 0.27 multiplied by 5 to 5.67 into 2 divided by 5. It is 55.82. It's 55.83 kilonewton per meter. Now the last layer. What is the tension developed due to this intensity of loading? So what is Z by B? Now it's 1.5. So Z by B is increasing to 1.5 and therefore I, J, M all will change. How much? 0.34. 0.34 multiplied by 0.9 minus 0.13 into 0.27 multiplied by 5 to 5.67 multiplied by 2 divided by 5. 56.96. 56.96 kilonewton per meter. That's the tension. That means it is acting as a slab. And when you are having the intensity of loading, it's going to, this whole zone which we have reinforced is going like this, more and more tension. Tension is increasing. As you go down, the tension is not decreasing, but as you go down, the tension TD is increasing. Here the tension was 52.2, increased to 53.7, increased to 54.7, 55.8, and 56.9. So friends, it's a beam effect. So reinforced earth. You can analyze it, how the things are changing. So Binkett and Lee research paper is milestone in quantifying the tension that is getting developed in the reinforcing layer. And whichever reinforcement you are procuring, the specifications will be guided by this TD. If the material you are procuring is having tensile strength less than TD, what will happen? It will get torn apart. It will fail in tension. And that's not permissible. And therefore, whichever geosynthetic material you are going to procure should have the tensile strength greater than this, with little factor of safety. Friends, my own research input, and I've guided many researchers for earning their PhD degrees, doctorate degree, and at MTech level. More than 50 dissertation on reinforced earth bed I have guided. 10 PhD students I have guided on this geosynthetic different level, but geosynthetic application. You should realize how the tension. So the tensile strength must be greater than this tension that is getting developed. Otherwise, there will be tension failure. Now, what is going to happen beyond this? Friends, try to understand. Very important. This is your locus of shear. Beyond this, whatever reinforcement you have, it is going to develop the friction. So this length from x0 to L0 is very important for development of TF, the pull-out force, the pull-out resistance. So what is the pull-out force? The frictional force that we will have to see. So let's write the second expression of TD. This is a very detailed research paper, and therefore it will take little time. You should have patience. And therefore the TF, the frictional resistance, F for frictional resistance, TF, can be calculated as 2 into F, where F is tan delta. The delta is the angle of friction between sandy soil and the geosynthetics, divided by a factor of safety. That factor of safety is also important. So that you should have in mind. So this is the value multiplied by linear density ratio. In our case, it is going to be 1, and delta is given to you. You can perform the experiment. The delta is given as 32 degrees. So friends, because the delta value is given to you, you can find out tan 32 degree divided by the factor of safety, that is equal to 3, and linear density ratio is 1 multiplied by now the load factor M, which is a function of Z by B. So Binke and Lee has given you these load factors J, I, and M multiplied by the width of the footing B multiplied by the safe bearing capacity Q0 multiplied by bearing capacity ratio, that is 3, plus the total unit weight of the sandy bed, that is 16.3. This is 525.67 kilonewton per meter square. B is in meter. It is a dimensionless quantity. So kilonewton per meter. This is kilonewton per cubic meter into L naught minus X naught is in meter. Now how will you calculate this X naught? X naught is the distance from the center of the footing up to this point, the locus of the shear. And that you can get it from the chart given by Binkett and Lee. So you will be able to get the value of X naught. Now this will be in meter. So it becomes kilonewton per meter square into Z plus dF. Z plus depth of the footing. So meter into meter, meter square. So it becomes kilonewton per meter. This is the second expression. To compute the value of TF. So now the next column, friends, will be the tensile, the pull-out resistance, and the unit will be kilonewton per meter. You can calculate it from the expression 2, and Binkett and Lee chart will definitely help you. So let's all compute it. The value of M is known to us. So here you will have to substitute the value of M. The M for Z by B equal to 0.3, you should find out the value of M. So M value is required. Without this, you cannot calculate TF. So for 0.3, it is going to be 0.12. And if you go to 0.6, it is almost same. Then you can go to 0.9. The value is 0.14. Then we should go to 0.15 approximately. And then it is 0.15 for 1.5. So it's very easy now. Let's calculate. Tan F equal to how much? Tan 32. So let's, you take your calculator and along with me, you calculate. So tan 32. 0.208. So it becomes F equal to 3. 0.208. So 2 into 0.208, then this is going to be for the first layer. M value is 0.12. B is going to be 0.9. BCR is going to be 3, and the value of X naught you will be getting depending upon the layer. So X naught is also to be found out from the chart given by Binky and Lee. So what is the value of X naught? That's also important. And if you substitute all the values, you will be getting the value of TF. And the TF, if I calculate here, so 2 multiplied by 0.208 into 1 into M value, which is 0.12, multiplied by 0.9 multiplied by Q naught multiplied by BCR plus gamma, that is 16.3, into L naught, which I have got from the Binkett and Lee chart, minus X naught, which I have got it from Binkett and Lee chart for the value of Z by B equal to 0.3. Z is already known to me, so it is 0.27 plus DF is 0.9. So friends, I am getting the value of TF as 76.2 kilonewton per meter. And the condition is, what is the condition? Condition is TD should always be less than or at the most equal to TF. Here if you compare, TD is less than TF. So friends, what should be now the total length? Because from the center line, it is L naught. So total length required is how much? What is the total length required? L naught. I have already explained to you what is L naught. Where the vertical pressure becomes, the intensity is going to be 1% of Q. So 2 times L naught. So what should be the value of L naught? It is going to be X naught by L naught by V is 1.25. So the total length, minimum length, will be 2 times L naught. For 0.3, the value of L naught by B for Z by B equal to 0.3, L naught by B is 1.25 from Binky and Lee. Therefore, 1.25 multiplied by B, that is 0.9, so L naught becomes 1.125 multiplied by 2. So 2.25 meter. So what is the minimum length? L minimum is 2.25 meter. So the value of L naught required, what is the minimum length? Is this here calculated? So we have already calculated the minimum length is this. Similarly, for this layer, this layer, this layer, the value of m is to be fed in the expression. Well, friends, it doesn't change much. And also the value of L naught and X naught should be found out from the chart given by Binkitelli. Z value will keep on changing. For first layer, it is, as you have seen, the value is Z is 0.27, second layer 0.54, and so on. Keep on substituting in equation 2 and get all the values of TF. Here, if you calculate, you will find the condition is well satisfied. So it is satisfied. Because it is satisfied, so K, I know what is the length, minimum length required. Provide little more. So friends, this is the design as given in Binky and Lee research paper. You won't get this type of problem in the textbook. You need to do it from various research paper. In the next video, I will come up with some new application of geosynthetics. Thank you very much. I hope you have liked it.